Hello and welcome, and in this video we're going to be covering factoring quartic trinomials. Now, the method that we're going to be using to factor quartic trinomials, such as this one, is actually the exact same method we use to factor quadratic trinomials, and we could factor quadratic and quartic and sextic and all up to a bunch of different types of trinomials, as long as it follows a certain pattern. Now, the way we would factor this particular trinomial is really no different than how we would factor something like this, or even this. The pattern that you should maybe see is that in each of these, well, it's a trinomial, all of these are trinomials, right? But in each of these, the last term is a constant, it has no variable, and the middle term has exactly half the exponent as the leading term. So in our original problem, we have an x to the fourth, the middle term is x to the second, it's exactly half the exponent, and then our last term is a constant. That's the exact same as our typical quadratic trinomial, where we have an x to the second as our leading term, and then an x to the first, which is exactly half the exponent, in our middle term. And same thing here, say we had x to the 10th as our first term, well, the middle term is x to the 5th, and the last term is a constant. So we can actually use the exact same factoring methods for all three of these. Now, if you haven't watched my video on factoring quadratic trinomials, make sure you go back and do that, because I'm going to kind of go through this fairly quickly, because it's the exact same way. Now, you could use guess and check, feel free to do that. I'm going to go ahead and show the long way. Well, the long way, remember, is that we needed to find two numbers that multiply to a and c, which in this case would be 2 times -6. So we got to find two numbers that multiply to -12 and add to our middle term b, which is -11. Now, technically, this is no longer a, b, and c, since this is a quartic and not a quadratic, but I'm going to continue using those same letters just so we are not confused at all. So I need to find two numbers that multiply to -12 and add to -11. And those two numbers would end up being -12 and +1. Now remember, when we are factoring quadratic trinomials, we brought down the last term, we brought down the first term, and we split the middle using these two numbers. Well, we do the exact same thing. I'm going to bring down the last term and the first term. I don't know why I'm saying last first. That's kind of weird. I bring down the last term and the first term. I did it again. And we split the middle using these two numbers, -12 and +1. The only difference is that when we were factoring quadratic trinomials, the middle term was just x. It was linear. So we just attached an x to each of these numbers. Here, the middle term is a quadratic. It's x squared. So the only difference is that we attach an x squared to each of these. And then we factor by grouping the exact same way we did before. So I'm going to go ahead and factor by grouping. In our first group, I could take out a 2x squared, which will leave me with 2x squared times x squared minus 6. And if I look in my second group between 1x squared and -6, I actually can't factor anything out. So I'm just actually going to factor out a +1, which leaves me with x squared minus 6. And once again, you should know how to factor by grouping by now, and we should see that this is going to work because we have a common binomial factor here. We have a factor of x squared minus 6, another factor of x squared minus 6, which means I can actually factor out an x squared minus 6. And that leaves me with x squared minus 6 and the leftovers, which is 2x squared plus 1. Now, the only thing we really need to be a little bit more safe about is checking to see if we can factor any further. When we were factoring quadratic trinomials, really the only extra thing we could do is check for a greatest common factor. Here, we still can do that, and you still should be looking for a greatest common factor first. But now that we're factoring higher level polynomials, you may encounter like a difference of squares at the end, where you can factor a little bit further using difference of squares. You could end up with something like a sum of difference of cubes if it wasn't a quartic, if it was something a little bit higher. But you could sometimes run into a sum of difference of cubes, which we haven't covered yet, but we'll be covering that in the next video. But in this particular problem, I can't break down x squared minus 6 any further. I can't break down 2x squared plus 1 any further. So this would actually end up being our final answer. Now, I want to go over just one more problem because this is so similar to factoring quadratic trinomials. If you have questions, make sure you let me know. I can always do a couple of more examples for you guys. Otherwise, let's go ahead and take a look at this last problem. Okay, so in this one, we have 3x to the fourth minus 14x squared plus 8. So the exact same rules apply. Always check for a greatest common factor first. This one does not have one, so I would go to factoring this trinomial. And once again, it follows that pattern. The leading term is x to the fourth. The middle term is x squared, exactly half of the exponent of the leading term. And the last term is a constant. As long as it follows this format, you can factor any trinomial using that exact same process. So in this problem, we're finding two numbers that multiply to 24 and add to negative 14. Now, if you want to go ahead and try to find that out and finish this problem, feel free to pause the video here and do so, but I'm going to jump right in. Now, two numbers that would multiply to positive 24 and add to negative 14 would actually end up being negative 12 and negative 2. Negative 12 times negative 2 is going to be a positive 24, but if we add negative 12 and negative 2, it's actually going to get us negative 14. So these would be our two numbers. So once again, we're going to bring down our first and last term and split the middle. And now we would factor by grouping. So I'm going to go ahead and group the first two terms and the last two terms and factor by grouping. In our first group, I can take out a 3x squared. So I'm going to go ahead and do that, 3x squared. And when I do that, I'll be left with 3x squared times x squared minus 4. Now in our second group, I can take out a negative 2, which will leave me with negative 2 times x squared minus 4. And as you can see, we are factoring this correctly because we have a common factor of x squared minus 4. Since it's a common factor, I can factor it out to get x squared minus 4. And my other binomial is going to be the leftovers out in front, 3x squared minus 2. But remember, we always want to see if we can factor anything a little bit further. Well, x squared minus 4 can actually be factored further because that is a difference of squares. X squared is a perfect square, 4 is a perfect square, it's subtraction, so I can use difference of squares. So x squared minus 4 could actually be broken down to x minus 2 and x plus 2. And now I gotta look at 3x squared minus 2. I can't factor that any further, so that is going to be our final answer. We have x minus 2 and x plus 2 and 3x squared minus 2. Those would be our three factors, and this would be our final answer. I hope this video was helpful. If there's any questions, please feel free to let me know. If you want more examples, just reach out. I can always make another video with just a couple of more examples. Please feel free to reach out. Otherwise, I look forward to seeing you guys in the next video.